Good evening, everyone, and welcome to OTF Connect. My name is Susan Watt, and I'll be moderating the session tonight. I'll be in the background for the most part, managing the chat, putting some of Scott's resource links in there, and for whatever question you might have about using Blackboard, just put your questions in the chat. Scott McKenzie is a teacher with the Waterloo Region District School Board. Scott and I are colleagues and friends, and I've moderated his sessions before, and he always brings a great wealth of knowledge and just sort of usability around some great concepts around coding and math. So Scott, I'm really happy to be here tonight with you, and I'd like to welcome you again to OTF Connects, and I will turn things over to you right now.
Thank you so much, Susan. It's a pleasure to have you moderating tonight. Hopefully everybody can hear me okay. If you're having any trouble with that, if you could just put something in the chat window, please. Hopefully you're hearing me okay. I'm coming to you from New Dundee, Ontario, which is right by Kitchener, and it's been a snowy day here. We had our Carnival and we were running around outside today, so lots of fun outside, and I'm glad to be inside now working with you tonight. Tonight we're going to go, and I decided rather than trying to do 4 or 5 projects and rushing through, I thought we'd do 3 projects and actually have time to build it. Oh, Plattsville, that's close, yeah. So we'll be able to take our time and actually build these tonight, which is kind of nice, and I'll talk to you about how I do that with students. Sometimes I give them a blank project, we create it together, or sometimes I give them a scaffolded project, so they'll start with a partially built project and complete it. And other times I'll have maybe 3 scaffolded versions depending on the students in my class, so that each student kind of has what they need to work with. But we'll see that as we go along. So, why coding? This is a question that comes up because it isn't specifically in the curriculum itself. So why do coding? Because it does take longer to introduce it to students, but it's a very powerful tool once you do. It allows students to think computationally, and computational thinking is a big thing right now. It's something that engineers do, it's something scientists do. It's something that we want students to be comfortable doing because it's a part of the real world. And as more and more things become automated and coded in their lives, being able to understand how those things work is important. Being creative, when they code, they can pretty much create anything. And that's the wonderful thing about Scratch that we're going to use tonight, is that there is not really too many limitations. They can turn a math lesson into a video game. They can turn it into an animated video, an interactive quiz. There's just so many different ways that they can take it. When they work through the design process, I'll talk about this more later, but they kind of have to develop it for a specific audience, and that's super important. Dot and dash, awesome, they're fantastic, and you'll get good use out of those, definitely, especially in elementary. Integrating math and language, we're going to do some of that tonight, where we're taking math and language and putting them together and tying that in with the coding. And real-world use, like I said before, just everywhere you look nowadays, things are becoming more and more digitized. And so for students, instead of just consuming that world, they can actually shape and create that world, so it's handy for them to learn how to be comfortable doing that. So here's where I'm going to let you use one of the clip art symbols. And if you want to take a clip art symbol, and maybe because we don't have huge numbers right now, you might even be able to check it off near the 1, 2, 3, 4, or 5 here on the page. So are you brand new? You have never really tried this before? You're a tinkerer? You're comfortable? You use it regularly? Oh, I saw someone was going to check Coding Ninja. I was going to ask you for some advice. A coder, you feel really comfortable using it, and you are a ninja. You branch a bunch of Raspberry Pis together in your spare time to create a supercomputer.
I also changed the polling tool to A, B, C, D, E. So if you want to use those for 1, 2, 3, 4, 5, you're welcome to.
Thank you, Susan. That's wonderful. Okay. So the room dictates the speed we'll move at tonight and what we'll do. So I'm seeing a lot of people in the brand new Tinkerer. We've got a coder as well, Jennifer, that's awesome. I'm probably going to go fairly slow, and we're going to make sure that these are applicable to you so that you can take these and work with these afterwards, because that's super important. So no ninjas tonight? Okay. And with 17 people, I'm comfortable if you want to use the talk button, so feel free to do that if you want to ask a question directly as we go. Okay, I'm going to move on. So, just talking about the importance of mathematics, this is right out of the Ontario Mathematics curriculum. And what's important here is that when principals or when other teachers ask us, hey, what can I do? How can I use this? Or how does it relate to our curriculum? I like to go right to the mathematics document. And right in there, I've highlighted in red, but we want students who can think critically about complex issues, analyze and adapt to new situations, and solve problems. Well, all of that comes out when they're doing coding. They have to think critically, and computational thinking is critical thinking because they're going step by step. They have to find often the one step that isn't working or is conflicting with something else. And as they build their code, it becomes more and more complex as the project builds. And they have to adapt to new situations where they change things, and they're solving problems constantly. After they build whatever they've created, then communicating their thinking is when they share their project and when they explain to other students how it works, which is half the learning. Down below, you'll see students need classroom experiences that help them develop mathematical understanding, learn important facts, skills, and procedures, which is what we're going to talk about tonight, and develop the ability to apply the process and have a positive attitude towards math. So when my students get to use Scratch to show their mathematical learning, that really excites them because it's very engaging to do coding. So being able to apply their math learning, especially sometimes some of those less exciting parts of the math curriculum, being able to apply those to coding is very beneficial. So here's an example, skip counting. When I was in school, this was worksheets, and we'd get a worksheet and we'd count by 6s, and then we'd count by 4s, and we'd count by 7s, and we'd just do it over and over again for a month until it became ingrained in us. And it worked. I mean, we did get that information. Automaticity became something that was there, but it wasn't fun. I can't lie and say it was fun. It just really wasn't. So what we're going to do, I'm going to show you an example I created for the students. I'm going to show you one of my students' examples of how they created their project, and then I'll walk you through how to create this project yourself. The link here is not live on the screen, but Susan has already put it in. So if you click on this link, the bit.ly, that is going to take you there. And I'm going to switch my screen now so that I'm on Scratch. So I'm going to take you there as well and play it for you. Oh, we're slow. Okay. So hopefully we are seeing on the screen. There we go. So if at any time things are really lagging, please put that in the chat window. Also, if you are having trouble hearing me, if it starts to lock up, again, please let us know. So this is my project here that I created in Scratch to show things full screen. We have this spot over here that we click on. And with pretty much all Scratch projects, to start the program, you start with clicking the green flag. Hopefully you'll be able to hear this. Embarrassingly, this is my own voice, but with some music that I also created with digital tools.
Count by sevens, count by sevens. Everybody is counting by sevens. Do you want to count by sevens? Then count with me. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. And let's go back again. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. One more time. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. And that's how you count by sevens.
Okay, so unfortunately the screen locked up a bit. I'm watching on my other computer here, and on the actual coding program it does stay in sync. It just locked up a little bit because we're running it live. So if we take a look, I can show you the code. This is a surprisingly simple program to build, and I added the cat. It doesn't have to be there, but the cat's in the program. But all the cat does, it's got the actual recording sound, and then I just have the cat shake slightly or dance while the numbers are animating on the screen. You don't have to have this sprite, but I usually put an extra sprite in. And then the only other thing here is the actual numbers themselves. And I'll show you, if I switch at the top, hopefully you can see on the screen, but there's scripts, and that's where we put the code in, and there's costumes. And if I click on the costumes tab, this is where I put in all the different numbers. So that does take a few minutes to do, and you try to keep them in the same spot. We'll do this in a minute. And once you're done, though, that's really all there is to it. That's basically the hardest part. The trick for the students is to then time the changes and their rapping or singing, if they chose to sing, to the actual numbers changing in their program. So I'll just give you a chance to see a student doing the same thing. And the link is also here. On the next slide. So you'll have this available to you later, and Susan's already put it in again. So we'll just go there now.
Scott, remember it's not the web tour.
And you could use this as an example for your class.
Scott, remember it's not the web tour, it's application.
Oh, Susan, thank you. Thank you, Susan. I apologize, everyone. Okay. So this is a pair of students. So my students generally work in pairs as opposed to working by themselves. That gives them that opportunity to collaborate, to work together, to discuss, and to debug or figure out the problems in their code by a discussion together and thinking through things and working as a team. So this is what they came up with. It's got some similarities to mine, and it's also a little different and has some student humor in it.
6 times 1 equals 6 times 2 equals 5, 6 times 3 equals 8, 6 times 4 equals 6 times 5 equals 30, 6 times 6, 36, 6 times 7 equals 42, 6 times 8 equals 48, 6 times 9 equals 54, 6 times 10 equals 60, 6 times 1 equals 66, 6 times 12 equals...
Okay, so when I give those students verbal feedback, I suggested the music perhaps a bit quieter in the other tab, and then other than that, though, it was pretty good. But of course, the comedy of the octopus injuring himself every time he ducks up into the times symbol, they quite enjoyed that. So if everyone is comfortable, what we're going to do now is I'm going to have you hopefully be able to follow along. If you have an extra device and you can do this on Scratch right now, that would be awesome. So what I'm going to do is I'm going to click Create. And if you want to follow along with me, then we can create this together, or you can just watch me, and then you can try it later. Multiplied by, let's do something simple, multiply by 5s. So you could do this, or skip count by 5s. You could do this with grade 1s, really. And what I'm going to do at the very beginning, I'm going to make this really simple, because some of us are new. A 2-finger tap on the cat on a Chromebook, or a right click, you can delete the sprite. And the character we see on the screen is a sprite. You can also do it down here in this box as well, and click delete. Once you've done so, then you can have these options. You can get a sprite from the library that's in Scratch, and there's a ton of choices. You can pick a certain category or theme and get different options. I'm going to click cancel, because what we're doing is we are painting our own sprite or creating our own sprite. So I'm clicking the paintbrush to paint a new sprite. Once I do so, the costumes. Some of the students in my class, they kind of did what I did, and they went to the text box and they double-clicked the text box, and then they counted by 5s. After they made that, then they went to the select tool, selected it, and then dragged it out to make it bigger, which didn't work here, which usually works. I don't know why it didn't. So we can create the 5 and then make the 5 bigger. I'll try that again. Okay. Okay, there we go. All right. That's one way you can do it. If you make a mistake, you have the back arrows here to undo, and you also have clear if you need to clear everything you were working on. A lot of students found it easier to simply use the paintbrush and then to actually paint the number. And this is all under the Costumes tab. If you get lost, please put something in the comments so that I can just kind of reiterate what we're doing. So with that paintbrush, it might look a bit thin. So if you go down here, there's a line width slider, and you can change how wide it is. And then again, so almost like an interactive whiteboard that is an animated thing that can do just about anything. So there I've created the number 5, and then if I click Paint New Costume right here, then I can put the next costume in. So then from here, with the same line width, I can do 10. Now I won't go too far, just for the sake of time tonight. But we'll get a few up here just so we can see how to code it. Why is it called costume? So Scratch is very kid-friendly, and I'll show you an example in just a second of why it's called a costume. So let's just, if I click back on scripts, everything in there is saved, that sprite. Let's grab a sprite just for a quick second. Let's grab the beetle here. So if I go to costumes, the reason it's called a costume is that I can change just about anything in this beetle. So I can click on the color red and the little paint bucket here. And if I click on this part of the beetle, it changes the costume of the beetle. It changes how it looks. It changes its appearance. So I can change, I can make this part purple. You can do all sorts of things. I can switch to vector mode, bitmap mode, and get my eraser. And then I can say, well, I don't want the back legs to be on my beetle. And I can start to erase those, take them out. I can do all sorts of things. So it lets me change the appearance of the actual sprite itself. Okay, so we've got sprite 1, which is our numbers, switching back to scripts. And event blocks start everything. So if I pull out when green flag clicked from the event blocks, which are this darker orange color, this starts our program. So when the green flag is clicked, I want, under looks, I want to switch to costume 1. And it's important to put this in at the beginning, because if someone stops the program partway through, if students just had this code block, which is next costume, then it wouldn't start back at the beginning. It would just continue on. So switching to costume 1 at the very beginning is really a good thing to do. Now, something else we need to have are wait blocks. A wait block tells the program not to do this instantly. So if I do switch to costume 1, switch to costume 2, switch to costume 3, and switch to costume 4, and I click the green flag, can you see what happened? Did you see the numbers change? In the comments, if you could write, did you see the numbers change from 5 through to 20? No, you didn't. Do you think the numbers changed? Ah, yes, Sarah's got it. It happened too fast. It happened instantly. So when you click the green flag at the very beginning of this program, what happened was it executed all those 4 things instantly. So it switched to costume 1, 2, 3, and 4 faster than we could see. So this wait block, I'm going to change it to decimal 5 for half a second. And with students in grade 4 and up, like decimals, it's a great way to talk about decimals. And I'm just right-clicking the block to create a few of them. So if I put a half-second wait in, now all of a sudden, I guess if we only have 4 costumes, it won't need the last one. So now let's see what happens. So now it's switching through. Students will have to work with these wait blocks in order to adjust for the actual timing of their beat. So I'll throw a 1 second in there for now, and 2 seconds will probably be what we want. Where I go, and I have this on the next slide, we'll go back to a little later, but where I go to get beats for students, I have them go to Incredibox or Button Base. Has anyone ever heard of these before? Thank you, Susan. Okay. So if I click on Button Base now, I don't know how well this will sound when I play it, but let's go to EDM. For students, all they really need is a beat, and they get to choose. They love using this. They love setting it up and designing a beat. So they might start with something quiet and then bring in more sounds. And then all they do is leave this tab open in the background. And as they leave this tab open in the background, they switch back to their program, which is here. And with that tab running and playing the music, what they do then is, and actually at this speed of beat, we might even be going at 0.5. they go to sound, and they pull out play sound pop. And we grab a run green flag click. It's going to run two things concurrently. And I'm clicking on the little black triangle, and instead of pop, I'm choosing record. The first time you do this, your computer will ask if you allow it to record, scratch to record, and you should click allow. I think it will ask twice, and then simply go. Pop. Here we go. Okay, and I'm going to stop it and start again. So this recording, I just clicked the little X to get rid of it, and I'll start again. Pop is just a popping sound, Melanie. 5, 10, 15, 20. So I've just got this little recording which I can test. And so what I'm going to do is go back to button base, and I'll just close it and pop back over here and play that.
5, 10, 15, 20.
So going back to my script, these 1 seconds, I'm pretty confident if I change those back to 0.5s, it'll actually work better. So let's try that now. And let's see what happens.
5, 10, 15, 20.
Okay. So interesting. It looks like we lost the recording. Oh, it's right here. Okay, if I get rid of pop, that should solve that problem. Okay, here we go. Or not go. So, and see, these are the sorts of things that will go wrong sometimes. So, I've lost the recording for some reason. This happens to the students as well. And it's good to teach them that it's not a big deal. Sometimes you just got to go through those steps a second time. So, and instead of button base now, why don't I show you Incredibox. Incredibox, there's different versions with different sounds. But essentially, each character plays a different sound. So you drag the helmet up, or the hat up, or the whatever it happens to be, and they make sounds. So if I have that music playing in the background, and I head back over here, once again I can record 5, 10, 15, 20. 5, 10,
15, 20. 5, 10, 15, 20.
So then we head back over to our scripts, and hopefully everything works this time.
5, 10, 15, 20.
Okay, and so you can see it's a little bit off.
5, 10, 15, 20.
So one of the things they can do, they can actually go here.
5, 10, 15, 20.
And they can actually shave a bit off of here. They can edit. Oh, we shouldn't need to do it that way. We should be able to just drag it to here. And we can delete by just dragging. We can delete the part we don't need, and hopefully that makes it all work together.
5, 10, 15, 20.
So in just working through this, the students are able to put everything together. Oh, Sarah, good question. Kids do use headphones, But generally speaking, what we do is we'll spread out. And so we have that whole talk about digital citizenship and not wasting their time. But generally everyone buys in because it's so fun to do. And they'll head down the hall. Some of them will go into the library for a few minutes and drive our poor librarian nuts. And they just find a quiet space, or they take turns. So there might be 3 groups in proximity out in the hall. And what happens when they're doing this, they're counting by 6s, something that they couldn't really do beforehand. So they practice, and they practice, and they practice, and they practice, because they don't want to make a mistake when they record it. And if they make the mistake, then they practice some more and they do it again. So they get really, really, really good at their 6 times tables, but they also effectively create the project as well. So if they're practicing, they're generally in the class, and when they're ready to record, they usually slip out into the hallway. Of course, if you're in a portable, that wouldn't be as easy. You might have to have them take turns doing it. Many of the students do use headphones to check what they've recorded and to hear it. So very simply, you draw the sprites and you get the music synced up, and that's really all there is to it for them. And then their creativity comes out where they'll start to change things. They might add sprites. One of the things I think that would be neat to do is they could create a visual of 20, a visual of 15, and a visual of 10, and a visual of 5, so that someone watching this would, and slow it down as well, of course, but they would be able to see 5 dots, 10 dots, 15 dots, and 20 dots. Just bringing it all together, the visual as well as the numerals. The stage itself, if I click on the stage, and I click on backdrops, white is okay, but it's one of the quickest things students change. I teach grades 3 and 4, generally speaking, Deborah. And I've done this with younger students as well as older students. And then you scaffold more for the younger ones, maybe giving them the music prepared and the timing so that they can work with the timing with you so that they get it all set up properly. With the older students, you might give them more challenges or have them do something more intricate where they're creating more visuals as they go. And for the stage, students always want to color the stage. So to color the stage, you would click on the paint bucket here. Again, I clicked on backdrops. I clicked away from scripts. Once I clicked on the stage, backdrops. And then you can choose any backdrop you want, really. Pink's selected here, so that's a nice bright color, searing pink. And that'll really brighten it up. So as you saw in my project, I had a cat dancing. Some of the students had different characters in theirs. One of the groups, they weren't quite done. They were having a bit of trouble. They were taking a little longer, but they did it in space, which was kind of super awesome. So they had a moon landscape in the background, and they were doing it all. They had characters from space, and they had a rocket ship flying across. So there's a lot of things they can add in as long as they're learning the math. Like we're you know, not memorizing, but just being very comfortable with counting by 6s or counting by 7s, counting by 11s. They did all sorts of things. They just really enjoy it. Okay, are there any questions about, is there a cheat sheet to help? Deborah, watching this again once it's out would be good. And going back to this project, so going back to the project, especially this one I just did here, I will share this, and Susan can share that link with you. I'll give the link to Susan, and you'll be able to go back to this simple project, start here with the students, and build from here. So you can take screenshots of these as well if you like and use those. But what we're also looking for eventually is, you'll see in here that it switches the costume and waits half a second, switches the costume, waits half a second. One of the things that we can start to do with this is we can start to introduce students as they become more comfortable with repeat blocks. The control blocks, they do something. They do something to other code that we have written or we've created or as blocks. So if I pull this out, I can get rid of everything else, stick in the weight block, and just pull out next costume under looks. And now, of course, for costumes, or actually if it's on costume 1, and this is the thinking they do, right? They have to work through. So if it's on costume 1, it will repeat 3 times because we have 4 total costumes. And then this makes the code much shorter than it was before.
5, 10, 15, 20.
And it does the same thing. Now I'm going to take that back out because I'm going to leave this nice and simple for you to get started with. And we'll bring this back out. Switch to costume and weight block in between. Just like so. Costume 2. And all these little step-by-step things students have to think through and they have to work through. And that's really important for them because as their projects get more complex, all the practice they've had doing this, they get really, really good at the iteration process where they go step by step. And it also increases their patience in doing math and solving math problems. It increases their patience with science experiments that don't go right the first time because we just liken it back to coding. And we say, well, when you're coding, does everything work perfectly the first time? No. And say, well, what do? Well, I go back and I go through the steps and I check to see where the problem is. And we apply that. We actually apply that same process to our problem solving, which is really great because then they feel successful in their math as well because it's just they know that it's just a matter of time before they get it all working. So if everyone's good, I'm going to move on to the second project. Any other comments or questions? Okay, not seeing anything. So what I'll do, I'll share this now. Scratch coding prompt cards. Oh yeah, absolutely, Jennifer. And there are resources out there, definitely. So if you search up OTF codes, this is searchable. So you'll be able to find this on Scratch later. If you search in the search bar, you'll find this simple little program. And you could start there with students. Okay. And Susan, I'll share this with you at the end of the session. So thank you. I'm going to move back to the slideshow now. So I hope you're seeing on the screen the octopus. Here are the links that will be available afterwards. So again, it was Incredibox, which has the beats, also Button Base, and there's Scratch, obviously, which has music built in. You can go to the sounds and you can pick from drum sounds, from piano sounds, guitars. There's all sorts of things that they can actually individually code as well. And there are copyright-free music channels on YouTube, and students can make use of that as well. And there's a ton. So they can pick some simple beats in the background. If they're writing a story, this is something I have them do. They'll get mood music, and they'll have the mood music playing while the characters are talking, either speech bubbles or the student voice is actually narrating what's going on in the story. With my students, I like to also, do you find students need a period just to play with? Oh, absolutely, yes. Sarah, I don't start with the Scratch project. I start with giving them an opportunity to do something with Incredibox or Button Base itself. And sometimes they'll do poetry over top of it early in the year, like say around Halloween. They can create music for that. At Christmas time, they'll often, or at a holiday time, they'll do different things as well. So it just gives them opportunities to play. Also, down here is image search on Google. Have you used or know the code.org lessons? Code.org is a great place to start with students. if that's the first step, that's fantastic and a great way to go. Once students are comfortable doing that, then you do want to move on. And to move on from there, if they're kindergarten, grade 1 age, grade 2 even, Scratch Junior is fantastic. As an app that they can use. It's on Chromebooks, it's on iPads, it's on Android. And then that helps them to get ready for Scratch, which can be carried all the way up to even first year high school. Like there's a lot you can do with Scratch because it takes away all the semicolons and all the things that they get stuck on and lets them think about what they're trying to do as opposed to all the syntax. But code.org is a great place to start. I added in here, image search on Google. Searching for PNG images. So if your students want to make a custom project and upload a different image that's not available in Scratch, if they search up a PNG image, it has no background, so that it's just the actual thing itself. If it's a baby chicken or if it's a bag of grain, then it'll just be that image, which can be uploaded to Scratch with no background. And what I do with my students right from the get-go is I teach them to look for copyright-free images. So on a Google search, we always go to Tools, and we choose the longest choice, which ensures that they're not choosing something that does have copyright. And it is a blow for them to realize that they can never actually use a Disney character because it's always going to be copywritten. So that's something that we learn as we go along, but that digital citizenship piece is important. Okay, next is taking a concept that we want students to learn, and this is the rounding elevator. So something I talk to with my students is when they have to round numbers, I always talk about 5 or more, up a floor, 4 or less, down is best. And then we take looks at different examples. So maybe numbers between 10 and 100, we round to the nearest 10. And then for numbers in the hundreds, we'll round to the nearest 100, and so on. And for the students, this little saying, it's a bit silly, but it seems to help them. So taking that concept and then coding it helps to solidify it for them so that they remember it better, and they can turn it into a mini game where someone can actually round numbers. So then they would input the numbers themselves. So I have here 2 links. Let's code together. We will try it together ourselves quickly. And then the completed project is also here for you afterwards, so that OTF Round will give you the completed, finished project with all the code, so that you don't have to worry about putting it together. So I'm going to go back to sharing screen. Please post any questions you have as we move. Okay, and here's the rounding elevator here. So again, for students, it's a great opportunity for them to record their voices, and right here, play sound until done. So it plays their recording. And if you have a younger class, this is a fantastic way to check their comprehension, because they can record their voice in Scratch and then share this project with you. Once they share the project with you, then you hear them explaining the math, and right away there's oral communication happening as well as their math comprehension, and you've got all that you can work with, and you can talk to a student, you can listen to it together, you can give them feedback. It's just a great opportunity to have a little sample of how they're thinking about their math. Now in this case, this is me again, so I'll just click the green flag.
When you're rounding, the elevator can help you. If a number is 5, 6, 7, 8, or 9, then it tells you to go up to the next nearest 10, 100, or 1,000. When the number is a 4, 3, 2, or 1, then you want to go down to the next lowest 10, 100, or 1,000. Try it now.
Jennifer, I see your question. Okay. So how I have them share, actually, believe it or not, is I simply have them go here to the project page and share their project. And my project's already shared, but if it wasn't, there'd be a button up at the top asking me to share my project. Once their project is shared, most of the students in my class will use this. So what they'll do is they'll actually put in RM9 or RM9 codes. It depends on the year. We pick different things. So I could find it that way. Another way you can find it is, here's the remix tree. So if you give students a project and they remix the project, which most of them do, you click on that remix tree and you can see all the student projects show up here. And you'll be able to click on the different projects and see what they've created. And the third way is I simply have them, once they've shared it, go to the top, take off the player, copy the web address, and I have them email it to me. We are a Google school board, so they all have Gmail, and they're linked to me, so they just share it through there. And I find that that's actually the easiest way, but the remix tree is great too because it's a quick way to see everything that's being created. And surprisingly, other than the students in my class, very few other people seem to want to remix my code, my elevator going that doesn't really move. So it's not something popular with other members of Scratch. Video games that someone creates might have hundreds of remixes, but this is the sort of stuff that really only the students in your class are going to be working with. So, just taking a quick look here, I'll walk you through questions and answers, because this is something that's great for students to use. And what happened here was we played the sound, the recording sound, and then we waited 6 seconds. I'm just going to increase the size of this here. Hopefully that's easier to see. And then I had it wait, and then the character is saying something. So again, playing it.
When you're rounding,
it plays the sound until done.
If a number is 5, 6, 7, 8, or 9, then it tells you to go up to the next nearest 10, 100, or 1,000. When the number is a 4, 3, 2, or 1, then you want to go down to the next lowest 10, 100, or 1,000. Try it now.
So what I'm doing with you is I'm giving you a scaffolded project, which is similar to what I would do with my students. So the 4 or less and the 5 or more, what this is doing is it's waiting until it's time for it to move, and when I'm talking about it, I have it turn 15 degrees, wait for 0.2 seconds, and turn 15 degrees the other way. This allows, the wait blocks allow us to see it moving, and it just wiggles to make it a little clearer. This is one of the techniques students do to kind of highlight something that's happening on this stage or the screen. These buttons here, the 60 and the 50, are invisible right now, and the final one, to do the 57, it looks like 75, but it's 57. To have 57 move, I'll just play this again. So I'm muting it, but as I play this again, you'll see that after it waits for the 24 seconds, then it shows. And once it shows, this button here has 5 and 7 on top of it. I'm going to show you what that looks like. Right now. And the 57 glides up under the 60. So all the code is here for that. And what that allows students to do is replicate that or create their own or more of those if they need to. And they can use this code here. If I take this code and I wanted to use this in a different sprite, if I grab on by the top code block and I drag it over and I drop it on top of another sprite, like the 60 here, when I click on 60, that whole stack of code has copied over here. So then that's available and would work there. I don't want it here, obviously, but you can create a block of code and add it to another sprite so that you can use something you've already created. I can't see questions right now. I'm hoping there aren't any right now. And use the talk button if you wanted to ask a question right now, please. So the elevator itself does nothing. It's just here. Students, a lot of my students would code this to move up and down slightly. They might have the words disappear and then have the elevator move up or down depending on what the answer was. And the cat is the one who's done the talking. So the cat says, let's round some numbers, and asks, when you round numbers, the elevator can help. And then, of course, after that, we want to ask a question. So here, we have to go to the sensing. Sensing blocks, they will sense different things. They might sense when one sprite touches another sprite. They might sense when a sprite touches a color. There's a lot of different options in here you can play with. But for us, and for these types of math programs, asking a question is going to be important. So our question is going to be, what would you round 36 to? And then it says wait. So what Scratch is going to do, our program is going to wait for an answer. So our answer is going to be the input that is given by the user of the program. And the user is going to give the answer. And I'm moving to the operator blocks, which are green, so that I can say I want the answer to equal. And so 36, I would want the answer to round up to 40. Hopefully that makes sense so far. And then I want this program to keep asking the question. So I'm going to the control blocks, and I'm going to say repeat until. So it's going to repeat asking the question until the answer equals 40. It will continue to ask the question. And I'm then going to add a little bit more logic in here. If I right-click this, I can duplicate this block. If answer equals 40, then say, and say is actually under looks because it shows up visually on the screen, say correct, or awesome job, or that's right, however you want to say. I find 1 second is long enough. And the else is if that doesn't happen. So if this is true, then say correct. And if it's not true, then say, and we could give a hint here. What does the 6 tell you to do? And you can add more clues, or you can just stick with that. So when I click the green flag this time, and I've muted my voice, but as it runs through, then it should ask the question, and we'll see what that looks like. And for students, this seems hard at first, but once they've done it once or twice, they actually get really good at doing it, and they can take this code here, and they can actually add it to their backpack. So this is something they could pull out and adapt later. So if I click down here on this little arrow, here's my backpack of different scripts. I even have sprites that I reuse. I'll throw them in here if I've changed the costume of a sprite. And I can take this part of the code block, and I can drag it down and just drop it into my backpack, and here it is. So the next time the students are using a project like this, they can pull that script into their backpack, go to their new project, open up their backpack, and drag it back out again. So that's really handy for them. So you'll see here, what would you round 36 to? And if I say to 30, that's not the correct answer. What does the 6 tell you to do? And it's going to keep asking until the answer is 40, which allows me to eventually, hopefully, get the right answer. Correct. Now, one of the great things about Scratch is that the students can modify and basically create anything they want. So if they create this program and then have another student work with it, and it doesn't work, or it's not working for those students, they can adapt their program based on their end user, because it's going to be different people using it. This might work for my grade 4 class, but my grade 3 students, they might prefer to have the number that moves up and down, or having the two choices, 40 or 30, show up, that little bit of scaffolding to make it slightly easier for them. I'm going to switch back to the slideshow now. Just bear with me for a second, please. Okay, have I missed any questions? Okay. How are people feeling? Am I making your head spin, or is it making sense and you're like, yes, I could use this, this might be handy? What's your feelings right now? If you want to type in the chat window. Okay, good. Okay, that's great to hear. Stephanie, that's awesome. And I do have a link I'll share with you. Here, I'll type it in this. Okay, that link there should take you to a whole bunch of Scratch projects I've built. They have a little video with them that scaffolds it for the teacher themselves, and you can use that to start with your class. You can play the video, which is me doing a screen share of a Scratch project and talking you through it, and then you can actually go to the pre-built project and work on it. I definitely demo and show it, Deborah. I go through part of the project, and then I have them do the part that I did, and then we go to the next section, we work through that, and then I always give them the opportunity for their creative freedom as well, so that they can make it their own. They can add the things that are important to them, but the concepts that I want them to understand, I definitely introduce. I always start slow at the beginning of the year, and I almost always tie it into art. So we do an art class as well, where we customize the sprites and we do different things, which is huge. And it gives a lot of different opportunities for the students who wouldn't always necessarily buy in. They buy in more, and then going to what they enjoy allows me to slowly pull them over to loving the math more and enjoying the computational thinking as well. Thanks for the feedback, everyone. We will move on. So this is design thinking. I just want to talk about this quickly because I think that with Scratch, it's a great opportunity. They're creating something, and they're creating an app, basically. And so what they're doing is they think of their plan, and they plan what they're going to build. And oftentimes they'll draw like little sketches of what it's going to look like. They'll start working through computationally through what they're going to have in their program, when it's going to have to happen. And then understanding who they're making it for is important. I've had them create things for younger classes, for younger students to get better at certain math concepts. Then they go through the iteration process. So they'll create kind of a prototype. They understand that that won't be the final product, and they'll test it out on someone and go, oh, okay, I see that when the student was working with the app I created in Scratch that they were having trouble because it went too fast. So then they go back and they'll adjust the timing and everything. They'll go test it again, and they'll say, well, it worked better, but I saw they got a little confused. So the part they got confused on, they think, why did they get confused on that part? And they think about the math, and they say, wait a second, it's hard for people to do division because they don't see the relationship to multiplication. So then they start with multiplication, and then they do the division, and they put it together so that it makes more sense for their target audience. And as they practice these different things, they themselves become much more competent in it, but it also builds their confidence in thinking computationally through building an app, and that's basically what they're doing in Scratch. So manipulatives are huge in math, and I kind of think of Scratch as a manipulative. So in the red, again, bolded, students need to understand making their own models is a powerful means of building understanding and explaining their thinking to others. And again, this is right out of the Ontario Mathematics curriculum, and I think that this is huge. So if students are creating their own learning tools to understand the math better, then they are going to use it because it's something that they themselves have worked through. And building it, they understand it so much better than just watching a video someone else has created. So, a story about spies and a hero who saves the day. So I'm going to share with you the full speech box version, and then what we'll do is we'll see one student's recorded story, and I'll show you how I scaffold that a bit too. So if I'll jump now to the first link and then to the second. Okay, and so this is what I might give to students who are a bit more advanced. And here what you'll see is there's a fair bit of code in here. This is not something I do at the beginning of the year. It's about this time of the year where students are ready for it. And in this, there is not too much going on except for the broadcasting. Broadcast blocks mean that one computer program will send out a message that other programs will run or other scripts will run, so that it kind of all gets timed together and works together. And I'll play this now for you, just full screen it. This is a story I made up for the students just to help them with concepts they had difficulty with, and I found in grade 3, sometimes grade 4 as well. And this is where it stops, because this was the part where students would take over and they would finish the story. So at this point, are we home yet on the bus? I've never had a grade 3 spell rhombus wrong in grade 3 testing ever, just because of this silly story, right? Are we home on the bus? And so from this point, then he gets back and it's a pen store, and there's always 5 pens at the front of the store, which is the pentagon. And so yeah, and I'll show you now. Here's a student who created, and you see here I've got my remix tree. So my remix tree, I can see different students that took this, of the different scaffolded projects I had, they remixed this one. And so this, what was I going to, I think I was going to share Ella's. Yeah, so let's see what Ella did. She's in grade 3, and she loves coding. And I think she did a pretty good job. It's not perfect, but it was a good first try.
Those 5 are 2 brothers named Prisiam and Piraam. Piraam and Prisiam caught Ezoid in a trap. They trapped Ezoid. But Ezoid was lucky because an alien named Hex saved him. He was so happy that the alien saved him that he kissed her. Hex did not like that, so she was angry. After Eva was out of the trap, he had to get past Priscium and Pura M's octopus named Octa. He got past Octa.
Okay. And so I guess she didn't finish the story. She did finish it in class, but maybe she remixed that again and did that again, or did it from scratch. I'm not sure. So they don't have to do all this coding here, which is a bit tricky, right? What I do is I build the harder part for them and let them work with the program. And then what they start to do is they start to tweak things. So they'll go in, and she had to broadcast the next stage, which was stage 6. Oh, actually, you can see stage 6 right here for her. So she has the pen store, and there's obviously something's not working in her code, so she's still debugging it. But she has her pen store. He does get back to the pen store, and for whatever reason, and I'm not going to debug it right now with you here, but going over it, there must be something that didn't allow that to broadcast properly so that the pen store didn't show up. But she's gone through the whole story, and there's her pen store, which she drew in Scratch. So she drew this right here. Some of the shapes that I did, what I did was I actually created this in Google Drawings, download as PNG file, and then upload to Scratch. To do that over here, you can see upload sprite from file. And then you can upload your very own sprites. I find it easier for some things because rectangle and circle are well represented, but other shapes are not so much. I have super creative students that are really good at drawing, and so they'll draw chairs and computers, and one student did a story recently, and she took one of the stories we wrote in class, and she actually coded it. So I gave them the option if they got done in time, and she coded the story in Scratch as an animation. So, and there's a bag of chips, and the chip flies from the bag into the boy's mouth, who doesn't like exercising and just likes to eat junk food. So it was rather amusing, and it's a lot of fun for them. But she's very good at doing the drawing. So different versions of this Ezoid story. I go here. So you can see Ezoid and the 2D Shape Adventure. I have different versions. And there's this version here which has all the characters but no code at all. So then the students would have to click green flag, they'd have to hide certain sprites and then have them appear at different times. Also, I have the student copy, which is with the actual speech bubbles. And we have teacher copy, and this is the one that I haven't shared. I didn't share it yet so my students wouldn't go looking for it, but this is what I would share with you. So again, here I'll put OTF codes, and that's searchable. And so this one runs through as well. But again, it's not completely finished. And even with something like this, what I've done is I've included in here problems. So this script here is not efficient. They could put a repeat block. If they changed a couple of things, they could shorten this way down. So what I do for my stronger students, I ask them to debug this program and to make it work better. So they'll cut this down and take the extra code out. I have a couple of things that don't run smoothly that I left that way that they would switch. One of the things I did was I created a stage 3, but nowhere in my program do I actually use stage 3. And so that's another thing that students could say, well, there's an extra stage and backdrop 3 that's not used in the program. So they could, there's a lot they could fine tune and clean up in here. And that's another way that they can work, especially the ones that are stronger. It gives them an opportunity to go in and debug a program. And I'll do this on purpose often so that students can work with it. Any questions about the and for students that then are able to do this, what I ask them to do the next time is I ask them to create their own story to help others. So right now there's a group of students that had me last year, so rather than do this, they're working on, they've got a 3D version where it's all 3D figures, and they're working their way through that. I think they're grade 4, so they're including a lot of quadrilaterals in their story as well. I feel like I've gone through this one pretty quickly. Again, I do most of the coding and then have the students finish the project. And I will show you maybe an example of that right now. And I've got to go back to this one here. No, that's the wrong one. So, sorry, apologies. This is the problem when you call them all the same name. I've opened it twice now. Here we go. Okay. So another student in the class who also finished, and he's new to our class, so he worked with another student who has more experience, but you can see his pen still there.
Oh, hi, I'm Zoid. This is Kira and Ecclesia. Oh no, I'm trapped. I'm trapped in Zoid. Yes, thank you. Hexagon. Now we have to get past Octo. Oh no! Octagon. Let's get past Octagon. Are we home yet? Are we home yet? Are we home yet? Ooh, the pen store. Let's go inside and tell them.
Okay, so you can really hear there what it sounds like when a whole bunch of students are recording at the same time. The students don't seem to mind that too much. Yes, Deborah, they're using the built-in microphone on the Chromebook. And it's not perfect, but they don't seem to mind that much. They all hate their own voices, but most of them get over that. The ones that don't, I let them put speech bubbles in for the characters, and they don't actually have to use their voice. I won't show you that because we've already watched this a couple of times, but I have an example of that too. One of the remixes does that. So basically, you can use Scratch in different ways for students. There's a lot of scaffolding you can do depending on their level and what they like to do. So if they don't want to talk, they can put speech bubbles. If they don't mind talking, then they can speak and they get all their information out. And for students that have trouble with writing or with reading, this is a great tool for them to show their learning as well, especially if you do some of the scaffolding of the program itself, then they can share a math concept. They also enjoy playing this for the other students, so watching each other's projects. Sometimes what I'll do is I'll throw a little website together and put all the projects on there. And then they can go and check each other's out, and they get a lot of fun out of that. And then you start getting them to give feedback to other students in a positive way, so that each person gives one piece of feedback to a group so that they can take that and adapt their next project when they work on it. Yeah, better quality external mics would be fantastic. I don't have a lot of access to that, but it does work. I find if the students have a quiet space, it works pretty good. I'm not quite sure what that banging noise was at the end, but yeah, they were right here in the class. They didn't choose to go somewhere quiet to record it. So, any questions, or is there anything you're wondering about with Scratch that you'd like to be able to do? I could maybe run through how to do something before we finish up tonight. sometimes even just a simple conversation between two sprites can explain a math concept, and I could show how to do that if you like. Yes, each piece of speech is recorded separately if you choose to. Angles, absolutely, I could do that. And Sarah, the first student you heard speak, what she did was she attached each speaking part to the broadcast block so that when a new script was broadcast to run, her speech was coming at that point. With the two boys that did this story, they recorded the entire thing from the green flag clicked, so there's different ways to do it. Would anybody else like to see angles? Okay, I see yours. So let's try that. Okay, hopefully you're seeing my screen show up on, there we go. Now, if I'm working with any sprite, a large sprite makes it difficult to do shapes. So up at the top here, you'll see the shrink arrows. I'm clicking the shrink arrows, pulling them down, and go in the center of that sprite, and you can shrink it down nice and small. This is better for making sure we can see what we draw. After I do that, I'm going to go to pen. Pen is green, a dark green, and I need to put the pen down. And pen down actually comes from way back when there were robots way back that students were coding, and they would have an actual pen that would draw on paper. Seymour Papert had students doing this years and years ago, and it was really cool. And so Scratch, the people who worked with Seymour actually created Scratch, and that whole concept of pen down has kind of remained. It was in the Turtle software as well that was back in the 80s that was out, logos. And so pen down will have this sprite now draw something. And let's say when green flag clicked, pen down, and I want my sprite to move. So if I pull out a move block, 10 steps is only 10 pixels. So if you move 10 pixels, that's not very far at all on the screen. So we're going to move 200 steps. And I'm going to click away from there so it stays. Now, once I've moved, I need to turn. So I'm pulling out a turn block. And with students, that 90-degree angle is so important in grade 3, understanding a right angle. So here's our first two blocks of code. And then to save time, I'm just copying those, duplicating those. Oh, and he's already started drawing because I clicked on them. Another script I like students to get used to using right away, especially when you're doing shapes, pull out a when space key pressed, and you go back to motion. You go to X0, Y0, the middle of the stage, or you can choose a different spot. And you want to point in direction 90. If you click here, it shows you what that means. 90 means to the right, which is the default for all sprites unless you choose differently. And finally, under pen, we select clear to clear off anything that's being drawn. So when I press the space key, it resets my program, and then let's see what happens. Interesting. Let's try that again. So we're getting a little extra with our cat. Let's see, have I turned too many times? 1, 2, 3, 4. Well, that's interesting. Let's change to 100 steps. I just want to see what's happening here. And Scratch, every once in a while, you get weird little things that happen with Scratch that you wouldn't expect. And if it happens, sometimes it's just refreshing will fix things. And right there, I just made it smaller. I think what went wrong was we went off the screen. And when that happens, it doesn't continue down here like it should or like it would. It doesn't go theoretically, so it hits kind of the edge of the stage down here, and it bounces back, and that's what caused it to go over up here. So if I clear everything, by making the steps smaller, I don't run into that problem, and I can create a square. Once I've created a square, hopefully the students, you can introduce them to a repeat block once and they'll use it forever. So if I get rid of all this, and repeat it 4 times, I've made it much less blocks of code, which means much less things that can go wrong. Now, you can change the color effect. These are the sorts of things students enjoy doing, so there's never anything wrong with it. But also what's kind of neat is it can turn into an art lesson as students start to play with this a bit. So if we pull out the change pen size and make that, say, 4, and I clear it off and run that again, now we've changed, oh, okay, I think I've changed the color effect of the cat. Oops. So all we need to do is go under pen, and we can change the pen color, and you can choose different numbers here to change how much the color changes. We'll just run that again. There we go. Now, if I add something in here, if I have my cat turn 15 degrees, and then I have my cat repeat everything in here, suddenly we've got artwork. And students love this. And once they've done something like that, then what I always say is, okay, what else can you make? So you've made a square, what else could you make? Can you make a rectangle? And so then they always go from what they've done here, and they try it again. So we'll clear everything off, and if they're going to do a rectangle, then they have to repeat twice, and one of the numbers has to be different. And then they create a rectangle. If they've created a rectangle, then I say, well, how would you draw a triangle? And so to draw a triangle, they think about it 3 times. And then we talk about inside angles and outside angles. And doing an outside angle for a triangle, and see, this is where they're already using the concept of a protractor without knowing what a protractor is. And what's really cool is once you've taught this, then take this and take these code blocks and print them off, like just take a screenshot of them, print them off, give them to students in class with some grid paper, and have them draw the shape that the code blocks are suggesting. And that really gets their computational thinking going. So if I say turn 120 degrees the outside angle, follows well in the universe, it draws a triangle. And then you can do the same thing where you can maybe move 5 steps, turn 8 degrees, and repeat all of that 10 times and see what happens. You start to get that 3D, and so I don't like the thickness. I'm going to, if you click on a block over here, just clicking on it makes it change. So then if I ran this again, it's now running it thinner. And if I repeat that 40 times, start to get a really neat spiral graph type program happening. Okay, how are we feeling? Do we have something we can take back and work with? I don't know about you, but I'm sick of my own voice, so you must be sick of listening to me by now.
Well, I think you've had lots of positive feedback there, Scott. That's awesome. Scott, I don't.
Yeah, good.
Scott, do you want to put it back
everyone.
to the whiteboard, and I'll do my little wrap up, and then if there's any last minute questions, you can ask. So thank you to Scott for just a great, well-paced introduction, I guess, for many of you to Scratch. It's been around a long time, and it's just such a great tool, and it's being so well used, I think, right now. And Scott is certainly inspiring many teachers locally and also beyond that through conferences and through OTF Connect. So thank you, Scott, for a really great, easy to understand, very inspiring and motivating session using Scratch. I'm going to stop the recording if that's okay with everyone, and I'll talk a little bit about OTF and some feedback that they would like. But I'd like to thank Scott just finally once again, and all of you as well for participating and for your questions and your responses and your discussion that happened in the chat. It's been a really great night.